In this presentation, I will share how space interval between 2 points appears with respect to different frames of reference having very high relative speed. Relativity of space interval means that space interval appears to be different with respect to different frames of reference having very high relative speed. Consider two inertial frames of reference S and S dash. Let the position time coordinates of an event be represented by x, y, z, t with respect to frame S and x dash, y dash, z dash, t dash with respect to frame S dash. Suppose initially at t equal to t dash equal to 0, both the frames of reference S and S dash completely coincide with each other, and then frame of reference S dash starts moving in x direction with a constant very high speed v, that is approaching speed of light c. Consider a thin rod AB held in moving frame of reference S dash such that length of the rod is parallel to x direction. Suppose ends A and B of the rod have coordinates x1, x2 with respect to stationary frame of reference S and x1 dash, x2 dash with respect to moving frame of reference S dash. So we can write real length of rod with respect to frame S dash L naught equal to x2 dash minus x1 dash, and apparent length of rod with respect to stationary frame S, that is L equal to x2 minus x1. According to Lorentz transformation equation for x coordinates of a point, x dash is equal to x minus vt whole divided by under root 1 minus v square upon c square. So x coordinates of two ends of the rod AB with respect to frame S dash can be expressed as x1 dash equal to x1 minus vt divided by under root 1 minus v square upon c square, and x2 dash equal to x2 minus vt whole divided by under root 1 minus v square upon c square. Thus, real length of rod with respect to frame S dash can be expressed as L naught is equal to x2 dash minus x1 dash. After putting the values of x1 dash and x2 dash from previous slide, we can obtain L naught equal to x2 minus x1 whole divided by under root 1 minus v square upon c square. And apparent length of rod, as we know, L is equal to x2 minus x1. Consider the ratio of apparent length to the real length of rod. Apparent length divided by real length of rod comes out to be under root 1 minus v square upon c square. So this result shows that ratio of apparent length to real length is less than 1, that is apparent length is less than real length. This fact that apparent length of rod is less than a real length of rod is called Lorentz-Feser contraction. It is to be noted that only those space intervals or dimensions of an object appear to change which are parallel to direction of moving frame of reference S dash. Other dimensions appear to be same as their real values. Thank you.